All right, this is a short video for the 6.5, the ready and the go. I forgot to include that at the end of the one this morning where we talked about just finding all the angles and everything for the task. So here it is. The ready is Pythagorean Theorem. That is a review. I'm not going to cover any of those problems. You need to go back and review Pythagorean Theorem, and you need to pick 4 out of the 6 to do. So you need to show me 4 out of the 6 on the 6.5 ready. It's all in Google Classroom, so go back and use that. For the 6.5 go, I'm going to talk about 13 and 15. Everybody all day has been saying 13 and 15, 13 and 15. 13 because it has the fractions, and I'm going to show you that it's not as complicated as you think. I'm going to begin by asking which fraction is larger, 1/2 or 3/4. And if I pose this line is 1, I'm going to go 1/4 of the way, 1/4 of the way, 1/4 of the way, until I get to 1. So 1/4, 1/4, 1/4, 1/4. Well, 1/4 and 1/4 is 1/2, and if I do another 1/4, that's 3/4. So right there should tell you that 3/4 is greater than 1/2. The reason why I want to do that is because I want to move the negative 1/2 x over to this side to keep my fractions, to keep my variable rather, keep it positive. So minus 1/2 x minus 1/2 x, and I get minus 7, because these cancel out, is equal to. Now, when I do that, what is 3/4 minus 1/2? Some of you learned how to add and subtract fractions horizontally. I learned vertically. But in order to add or subtract, you have to have a common denominator. So change the 1/2 into something fourths. 2 goes into 4 twice. 2 times 1 is 2. My new fraction is 2/4, which gives me 1/4 is left. So 1/4 x minus 8. I add 8 to both sides. 1 is equal to 1/4 x. What number times 1/4 is equivalent to 1? Well, if this is a division, I multiply by the reciprocal to get rid of the fraction. So when you multiply both sides by 4, 4 is equal to x. So there is 13. Didn't seem so hard now that we went through and did it. When you look at 15, okay, 15 looks intimidating, and there's a couple of different ways you can do this. Believe it or not, this is a proportion. It's a little bit more complex than, say, 12 over 15 equals x over 10, which is one we saw earlier. This doesn't have pluses and stuff in it and multiples. This does. But we still solve it the same way. I still cross multiply. 9 times x plus 5 is equal to 6 times 3 times x plus 2. Now you could do this the long way and you could distribute. 9x plus 45 is equal to 18, which 18 times x is 18x. 18 times 2 is 36. You could do it this way. Well, if we continue, it's a whole lot of moving things around. It's 9x, 9x, so 45 is equal to 9x plus 36 minus 36, right? I know I'm going through it fast. If you need to, pause it. Okay? 45 minus 36. 4 minus 1 is 3, 15, that's 8, 9. 9 equals 9x, and divide by 9, and x is equal to 1. Now there's another way you can do this. When I get to here, 9 times x plus 5 equals 6 times 3 times x plus 2. I can avoid a step in here. And I'm going to avoid a step by dividing by 9. X plus 5, don't need the parentheses. X plus 5 is equivalent to, if this was 18, like we said it was here, I can cancel that and reduce it to 2. 2x plus 2. Which is x plus 5, which is 2x plus 4, and the only difference is I'm working with small numbers. Believe it or not, these are equivalent equations, these two right here. If I take this entire problem right here and divide by 9, 9 will go into 9, 9 will go into 45 5 times, 9 will go into 18 twice, 9 will go into 36 4 times. Now all of a sudden it's just a matter of minus x, 5 is equal to x plus 4, 1 plus 4 is 5, so x is equal to 1. All right, so there's your 2. Now out of this section, you need to pick 4 more. Make sure you show your work. So 6 total in that section.